Hi, this is Mrs. Poland, lesson 6.05, more on confidence interval. Example 2. A company has received complaints about its customer service. The managers intend to hire a consultant to carry out a survey of customers. Before contacting the consultant, the company president wants an idea of the sample size that she would be required to pay for. One value of interest is the proportion P of customers who are satisfied with the company's customer service. She decides that she wants the estimate to be within 3 percentage points at a confidence level of 0.95. Using a conservative estimate of P hat, how large of a sample is needed? Okay, so they're asking for the minimum sample size that's needed in order to have a margin of error of within 3 points. So your margin of error has to be within 3 percentage points. So we're going to start with the definition of what the margin of error is from the formula. So normally the whole confidence interval would be plus or minus, P hat plus or minus the critical value times the standard error, which would be P hat Q hat over N. So the margin of error is just what I'm circling. So basically we want the critical value times the standard error over N has to be less than or equal to 0.03. So what is the critical value? Well, we know we want a confidence level of 0.95. That means alpha, what's left in the tails, is 0.05. If I divide that in half, that's 0.025. And so to get the critical value, you're going to do plus or minus inverse norm of 0.025, 0, 1. And we've already had much experience with that, and that turns out to be 1.96. Now, in this case, there's nothing in the problem to lead you to know anything about the point estimate, but we do want a conservative estimate. So in order for this estimate to be conservative, it means like a much larger value of N than we actually need. We really want to see, to make this value conservative, the highest possible value of P hat Q hat. So I want you to put the video on hold and see if you can figure that out. So what I've done is I've selected various values for P hat and Q hat. So if I chose P hat to be 0.1, then Q hat would be 0.09, and I would get 0.09 as my product. If I chose P hat as 0.2, then Q hat would be 0.8. That would give me a product of 0.16. If I chose P hat to be 0.3, then Q hat would be 0.7, and that product would be 0.21. If I chose P hat to be 0.4, then Q hat would be 0.6, and my value would be 0.24. However, if I chose P hat to be 0.5, then Q hat would be 0.5, and I would get 0.25. Once I start choosing higher values for P hat, Q hat starts decreasing, and it turns out, so like if I chose this as P hat as 0.6, this would be 0.4, and notice how it's starting to go down. Okay, so the maximum product would be when P hat is 0.5 and therefore Q hat is 0.5. This would make the numerator as large as possible, and that would give me a conservative estimate of N. So I'm just going to rewrite this information down here so it's a little bit more room. And again, you only estimate P hat with 0.5 if you have no idea of a value for the point estimate. And this has to be less than or equal to 0.03. Now, you can use various algebraic techniques in order to solve for n, but we can use NSOLVE in this course because our focus is not on the algebra. So to use NSOLVE, and I'll show you in the calculator in a second, you would write the equation. So you would just type in directly as is. You can't use N unless you have a CAS calculator, so we'll assume that people don't. So you're going to use X. You're going to set the expression equal to 0.03, and then you have to remember comma X. So let's go to the calculator and try that. Again, you have to be in a calculator page. You would hit Menu, 3 for Algebra, 1 for Numerical Solve, and you would do 1.96, control square root, control division, 0.5 times 0.5. Well, that's not a point there. Okay. So you would type again the equation in, make sure to set it equal to 0.03. Remember the equal is in the same row as 7, 8, 9 towards the left. And then make sure it's comma and the variable that in this case we're using X. And when we get our answer, we get 1067.11. And with these problems, since n has to be greater than or equal to that amount, you're always going to round up no matter what. So this final answer would be 1068. That would be the minimum sample size that they would need to be within 3 percentage points given a confidence level of 0.95. Part B. In the company's prior year, 80% of the customers surveyed said they were satisfied. Using this value as a guess for p hat, find the sample size needed for a margin of error to be at most 3 percentage points with a 95% confidence interval. How does this compare with the required sample size from Part A? So this is where they actually gave you a value for a point estimate that they're using based on a prior year study. So instead of using the conservative estimate of 0.5, we're going to have the higher value of 0.8. So again, the margin of error is going to be the critical value times p hat q hat over n, and again we want it to be within 3 percentage points. So the critical value stays the same at 1.96 because we're not changing it from the 95, but instead of entering 0.5 for p hat, we're going to enter 0.8. Therefore, q hat is 0.2, n is what we're solving for, and we're keeping the margin of error the same. So we're going to go back into the calculator. We're going to do menu, algebra, option 1. Actually, I have to start over on that. So we're going to enter 1.96, control square root, control division. We're going to enter 0.8 times 0.2 over x. Then we're going to slide over equals, okay, so I re-entered it in, and now you press enter. Okay, and let's see what I am missing. Sorry about that, I had an extra equal sign, but this should be good now. And it is, you get 682.951. And again, you always round up. Notice that the sample size is significantly smaller than Part A, and that's expected because we're no longer using a conservative estimate since we have information from the prior year. Part C, what if the company president demands a 99% confidence instead of a 95% confidence? Would this require a smaller or larger sample size, assuming everything else remains the same? Put the video on hold and think about that. So let's see what happens. We're still looking at our margin of error. So let's get that out. The margin of error is equal to the critical value, which now is going to change. P hat and Q hat are going to remain at 0.8 and 0.2. N is what we're solving for, and we're still looking to be within 3 percentage points. So we now have a confidence level of 0.99. That means we have in the tails 0.01, and if I divide that in half, I get 0.005. So to get the critical value, it's going to be plus or minus. We're going to do inverse norm of 0.005, 0, 1. Okay, and let's check that out. So we're going to do menu, statistics. We're going to do distributions. We're going to do inverse norm, 0.005, 0, 1. And when I enter it in, I get plus or minus 2.576. So this is going to be 2.576, the square root of 0.8 times 0.2 over n. And that has to be less than 0.03. So let's go back to NSolve, menu, algebra, numerical solve, and we're going to do 2.576 and control square root. Where's the square root button? Control division, 0.8 times 0.2 over x. And let's scroll over, equals to 0.03, and then we're going to do comma x. And let's press enter, and we get 1,179.69. So n has to be greater than that amount, so it would have to be a minimum of 1,180 people. That would be expected because you're increasing your critical value. That means you definitely need more people in it. Okay, I hope that helps, and we'll do another video on the next problem in a moment.